Yes, Indu ma'am.
Yes, sir.
Now time is 12:30.
It's 12:30.
Then Akshay sir, can we start, sir?
Yes, please start.
Okay. Good afternoon, sir. Good afternoon, Akshay sir.
Good afternoon.
Good afternoon, all participants, and to expert of the session, Dr. Akshay Dwivedi, sir, in the first technical session of this FDP on design thinking. This is pleasure for me. This is a matter of pleasure for me to introduce Dr. Akshay Dwivedi with the participants. Professor Dwivedi did his PhD from IIT Roorkee in advanced manufacturing processes. He did his MTech from IIT Roorkee as well and BTech from Jivaji University. Professor have areas of interest as advanced manufacturing processes, non-traditional micro machining, metal matrix composites, primary and secondary processing of MMC, quality management, QFD for service sector. Professor Dwivedi awarded many times for best research papers and as best teacher also. Sir worked and working on 7 sponsored projects from various organizations like DST, MHRD, CSIR, etc. Professor authored and edited 58 various book chapters and conference proceedings. Sir supervised 18 PhDs and having more than 100 research publications in reputed international journals and conferences. He is member of many professional societies and conducted many conferences as well. I again welcome you, sir, and we are very thankful to you for accepting our invitation for being expert in this FDP. Sir, I now request you to share your wisdom with us.
Thank you, Dr. Indu. I hope I am properly audible.
Yes, sir.
My
Yes,
voice
sir.
is not fluctuating.
It's clear, sir.
Okay, so let me share the presentation with you. Can you see the presentation now?
Yes, sir. It's visible.
All right. So, dear participants, I thank Dr. Ranjit for inviting me for delivering this particular session on design thinking to you. And though Dr. Indu has given a wonderful introduction, and especially in the introduction parts, he has mentioned that I'll be talking technical things to you. But please be assured, I will not be talking anything which is too technical. In fact, what I'll be talking about is how to bring in your particular thought process in a way so that something real beneficial comes out for the society. We'll be talking about what design thinking is, how this particular approach is followed, what are the different ways, what are the different tools and techniques that we use here. And we'll be learning about that, okay, if you have to develop a particular product using this particular approach, how to do that particular thing. And idea here is that we will be talking things in a way where you can actually implement this particular design thinking in your own environment. And when I say own environment, basically I assume that all of you are faculty members at some particular engineering college or some particular place, and you are involved with students, how you can actually involve them into this design thinking approach, and you can actually develop something good for the betterment of society. To give you sort of a starting point, I will be having certain questions from you, and I hope you can give me some answers for that. Uh, by the way, whenever we talk about any product or let's say any process which we have to develop, usually there will be a problem, and we would like to find solution of that particular problem. In a scenario where you have, let's say, everything is fine, in that particular case you will be of course looking for something which is referred as area of improvement. So whatever that is existing, can you improve that particular thing? So that requires sort of a thought process. How to come up with that particular thought process, that is what we'll be discussing in design thinking. Of course, one of the most important requirement here is we have to be innovative. We have to think in a way where maybe others have either not thought or maybe not thought in that particular specific way that is really the requirement. So before you I start, I have one figure in front of you. Can you see the slide, which is slide number 2?
Yes, sir.
All right. So what has happened here is this is a low height bridge, and this particular gentleman who was driving the truck has actually went under it, and without realizing that the height of truck is slightly more than what can actually pass from the bridge. So can you suggest a solution what we can do here? Should we take this particular truck back so that maybe the road gets cleared and maybe there is a possible traffic jam, that situation can be avoided? What can be done? Can you help me here in this particular specific problem? What can you suggest? Or should I dismantle, let's say, the iron structure which is creating this particular bridge, and maybe take this particular truck ahead on the
We can
journey?
remove air from
We
the
can remove
tires, sir.
we can
Oh,
remove air from
wonderful.
the tire.
Wonderful. So will that work?
Yes, sir. So when air is removed from the tires, the truck will lower, and so we can remove it easily from there.
Perfect. So in this particular case, let's say if you do not have access to a compressor, so once you remove the air, you are not able to fill that particular air back again. Then what you will do? Any option? Or should we close this particular road? Okay, now the truck has entered into that particular zone where it cannot be moved. We do not have access to the compressor, and maybe so if you remove the air, the truck is going to be very heavy, and you have to leave it there only.
Sir, we can reverse the truck. That can be done.
Okay, so maybe in that particular case, if that by while reversing there is some damage to the truck or the bridge, will it create a problem?
Maybe.
Maybe it can happen. See, when we
Even
talk
if
about
we lift the bridge also, there might be some we cannot lift the bridge. That is, I think, impossible task.
oh, what fun if the problem is not too complicated. Why do we want to actually solve it if it is not a complicated one? See, the first idea that you provided for this particular problem as a solution was wonderful. And that particular solution was basically where you realize what is going on with an environment, and then you identify that, okay, what is the best way to deal with this particular thing? So that is usually a problem solving approach. Now, when we talk about, let's say, a problem solving approach, can we actually think about design thinking as a particular tool, how to do it? If we have to use that particular thing as a tool, what are the different steps, how we can actually go ahead? Now, I have something which is related with Isaac Newton's theory of gravitation. And basically, you may have heard about this particular story that an apple fall down and somebody identified it as an informative event. Basically, this particular gentleman was Newton, and he identified that, okay, there can be a logical conclusion which can come up. And that particular logical conclusion basically resulted in theory of gravity, and we all are using this particular gravity in our daily life, whether it is traveling in sort of a lift in an skyscraper, or even in that particular case where you are moving on a road, because gravity will be resulting in some kind of a friction, and that is why you can actually move from one place to another by using any kind of an automobile. So when we have any kind of an information where that particular information can actually result in something which is good, which can actually be provided to some kind of an application, that should be the job of an engineer. So in this particular case, there is another aspect which comes into picture. So have you seen this particular symbol?
Yes, sir.
By the way, this is a dollar sign. Have you seen this particular symbol?
Yes, sir.
This is rupee sign. Simple. Uh, while somebody designed this particular rupee symbol, and if let's say if I have to criticize this particular thing in a way that it is nothing but a copy of what dollar had. So dollar had a S by which was basically given sort of a vertical line. In rupee, you have a Hindi word mala R and you have a horizontal line to it. So what is the fun in this entire thing? But the thing is, we all are using this particular rupee symbol every day, and we have this particular symbol in our wallets every day when we move out from our houses. In fact, we are using this particular thing. So, does it provide sort of a recognition? Answer is of course yes. By the way, it was 15 July 2010 when a person who was able to draw logical conclusion and acted upon them, Professor Uday Dharmalingam of IIT Guwahati, head department of design, who developed this particular wonderful symbol. See, idea wise, this may sound very simple, but in practice, in terms of application, this particular symbol has got great value and we all are using it. So, in case if we have to go with, let's say, design thinking approach, we need to understand that whether whatever that we develop as a product, whether that particular product will be useful for the society or not. And if that can be useful, far simple the design, far complicated the design, that particular design will be a good design. Here, in this particular case, if somebody has to define design thinking, we need to understand that design thinking is both an ideology and a process, which is concerned with solving complicated problems in a highly user-centric way, wherein user comes at the top level. So in this particular case, let's say if we have to understand when design thinking comes into picture, you have to actually innovate something. You have to come up with something which is new. Now, in this particular case, one thing which now comes in is, why do we innovate? The answer is very simple, just to make things easier. For example, there was an old telephone and now we have these particular touchscreen mobile phones. For example, there was a tricycle and now we have race cars. Maybe very soon we will be having too many of electric cars coming into the same domain. We had those particular fountain pens where we have to dip those fountain pens into an ink bottle and then we used to write it. And now we have those particular easy to use ballpoint pens. So whenever there is some kind of a new product development, it basically provides us a better way to do the things in a way. And more or less, the user comes into the top priority part. So if the question comes as who can innovate? Can I innovate? Can you innovate? Or maybe can your students innovate? Or all of us can innovate? So here for this particular thing, there are certain important questions which we need to answer. And if for we have answers to those particular questions and we inculcate those qualities into it, we all can actually go into that particular innovation domain. One important thing which I would like to stress here is, see, over last few years or so, we have realized that engineering, especially in terms of, let's say, core branches of engineering, has left the interest part in the mindset of students. Everybody is too eager to learn about what is going on with data science. Everybody is too eager to learn what is going on with artificial intelligence. What happens to those particular engineering trades where electrical engineering comes into picture, or mechanical engineering comes into picture, or civil engineering comes into picture? Maybe there is a issue with the kind of mindset that we are having right now, or the kind of ways that we have been dealing with the things in a way. And now it is the time to reframe or rearrange that particular thing. And in that particular aspect, if we can understand really what are the requirements where people can actually innovate, and for that they use certain design thinking approaches, something good can actually come up. We can again restart that particular interest of people to come and work in the right spirit. So when we talk about innovation, and let's say when we talk specifically in terms of engineering, we are talking about something that we know and we try to apply that particular thing in a particular domain. So basically learning plus application. That particular thing, when you club together, usually we refer to as innovation. Now, who can do it? The answer for this particular thing is everyone can do it. Basically, if there is someone who can ideate to address a specific challenge in society and provides a feasible solution, that particular gentleman or a lady can do his or her parts on the part of innovation. For this, the specific requirements are: you have to be curious, you have to have knowledge of science and technology, you want to make certain changes, and most important thing is you have to actually care about the society. And if you have all these particular four traits, the most important requirement is you should have a positive mindset. Now, positive mindset here implies you have to be constructive, not destructive. Now, in this particular case, if we have to start with, the question that now comes in is, can all of us do it? The answer here is how. And to understand these, there are certain steps which comes in. Now see, when I had shown you that particular figure where truck was beside under that particular bridge, the first thing that you had is, okay, you had a visual in front of you, and with that particular visual you identified that, okay, there is a constraint, and that particular constraint is the bridge height. And if I have to find a solution for that particular thing, I need to lower down either the height of truck or I need to increase the bridge height. So increasing bridge height becomes impossible. Lowering down the truck height is possible just by removing of that particular area. So basically what you did is you identified some kind of a way where you related with the environment, you understand with those particular constraints, and this is something what you refer as think inside the box. There are certain objectives which needs to be fulfilled, and for those particular objectives there are certain constraints, and you are just finding a solution for that. And in fact, this is the first step usually whenever we talk about any kind of an innovation. This may sound like a case that, okay, what you are doing is you are just copying something which is already there. But one important thing to remember here is, whenever we talk about, let's say, design or sort of a redesign, there are certain rules which comes as sort of a principle for design thinking. And let me name all those particular rules one by one. First and foremost rule that we have to understand with respect to design thinking is the human rule. And this human rule implies that no matter what the context is, all design activity is social in nature. And any social innovation will bring us back to something that is a human centric point of view. So basically, how you relate with that environment, how the customers relate with your environment, in fact, how the stakeholders they relate with that particular environment, and that particular thing, understanding of that particular thing, and coming with a solution from that, that comes under the first rule, that is human rule. The next rule that comes out is ambiguity is inevitable. It cannot be removed or oversimplified. But experimenting at limits of your knowledge and ability is crucial in being able to see things differently. So even if you are going with thinking inside the box, you have to first understand that, okay, the kind of tools, the kind of knowledge, the kind of background that you have, that will be the first starting point. The next rule comes out is named as redesign rule. Remember, all design is redesign. While technology and social circumstances may change and evolve, basic human needs remain unchanged. So we essentially redesign the means of fulfilling these needs in reaching something, let's say, a desired kind of an outcome. So even if it may sound like reinventing a wheel, but making this particular wheel to work in a way where it is far better than the previous generation. That is how things actually evolve. The last thing which is very important for design thinking is, whatever that you develop, whatever that you have in your mind as sort of a design, there has to be a tangibility to it. And this particular thing is named as tangibility rule, where ideas tangible in the form of prototype can enable people to realize that, okay, this is something which is new, and you can actually use it as a feedback to receive for the new products, new development that you have. Now, in this particular case, there are few more other ways which now comes in, which are out of the box thinking. So whatever that is there in front of you, you can even think about something which is quite outside. So maybe when we talk about this particular truck example from where we started, and I gave you a particular scenario that you do not have access to the compressor, so the first suggestion that came up actually was not able to be fulfilled here. So in that particular case, can you do something about more than that? So, is it possible that maybe someone can suggest removal of all those particular tires and then provide sort of a way to roll out this particular truck ahead, and then taking this particular truck away from the bridge part? Maybe somebody can suggest in this particular case, okay, you do not have a compressor with you, but is it possible to have compressed gas transferred to this particular truck? So that maybe once you remove this particular air out, you can actually remove this particular truck under the bridge and then use the compressed gas to fill the tires again. That is again a possibility. The idea here is whenever you have to innovate, if you reach at the last level, which is, I don't think inside the box, I don't think outside the box, I don't even know where the box is. So is it possible to dug the road beneath the truck so that maybe the height between the road and bridge then increases, and then you can easily swiftly pass on this particular truck, and maybe this particular idea can sustain over a longer period of time, because what you are actually doing is you are not doing a temporary kind of a change on the truck height or the bridge truck height, but basically what you are doing is, since you are making sort of a depression under the bridge, for that particular thing will be increasing the overall height for a longer period. So maybe that can another way where this particular solution can come into picture. Now, when we talk about innovation, there are few important things which we need to understand. The first is, what is your passion? Are you passionate about something? The second thing which comes out is, what is your profession? When we see about profession, basically we are talking about the tools and techniques that we know. And once if you understand this particular thing, and if you live, let's say, your profession with a passion, and it also come out as a vocation, that is going to give you some kind of a monetary benefit as well. But the thing is, you have to work on this particular thing in a mission kind of in mode. So if we have to actually start this particular entire innovation journey, there has to be some important starting points from where we can start. Now, to answer them, the first question that comes in is, what is your passion? For example, let's say I belong to a field of mechanical engineering. I also work in field of production engineering, industrial engineering, quality management, advanced manufacturing. From past few years, I have started working on development of products, wherein I am working for development of healthcare devices. I am working for development of surgical instruments. I am also working on certain cases where artificial intelligence comes into picture. That sometimes involves some electronic circuitry, maybe hardware, and then certain software and clubbing of all those particular things. So, is this my passion? The answer for this particular question is, I have a passion to break the things and then join those particular things. And in fact, everybody here will be having this kind of a passion somewhere during their lifetime. Whether as a child, you had a new toy, you played with that particular toy. After 4 or 5 days, you identify that, okay, the toy has lost its value. Maybe you just opened it, make it things apart, and then try to find out, okay, how I can assemble that particular thing again. If you are able to assemble it, wonderful. You are now basically working in the direction of your passion. Maybe 2 times, 3 times, 5 times, maybe 20 times you fail. But if you keep on continuing doing that particular thing, the 21st time you will be able to assemble it properly. And maybe with that particular assembly, you will be bringing in a new feature, a new dimension to that particular product. So idea here is, first and foremost thing is, identify what is your passion. A simple way to deal with this particular question is, what would you like to do if you have nothing to do? What do you do in your free time? Do you play? Do you read? Do you watch television? Or maybe do you listen to music? Or maybe if you play music, or maybe you play cards, or maybe you do just some chit chat, or you do some kind of a social networking. If that is something which is coming out as your passion, wonderful. That can be a starting point. So, if with respect to your passion, you can identify something which can have a high impact to the society, that basically makes you work in a right direction. And let's say if with your passion and if you have some kind of knowledge of tools and techniques, which is basically your strength, you identify a particular problem which can have high impact, you will be more than happy to work in that particular direction. And mind it, 99.9999% times you will be getting results which will be far better than what is existing right now in the society, because your passion and your strength, they both have clubbed together, and you are working towards something which is having a very high impact. We have to find out that particular set which is common to all these particular three things: passion, strength, and high potential. This is basically the best problem for you. Now, you need to answer this particular question on your own, where you have to identify your passion, your strength, and then work for that particular high potential impact. Now, let me give you some examples about what a high potential impact is. Right now, it is winters, and we are having what serious cold these days. So everyone is using, let's say, heaters. All right. So maybe if you are passionate towards developing new products, wherein this particular product can be a heater, if you have knowledge about, let's say, certain chemistry, certain metals, certain non-metals, certain electricity, you know how to control the resistance so that you can develop a particular heater which can be used by society. Will it be a good problem to work on? What is your answer here? I'm waiting for a response. Should you develop a new type of a heater for society? I'm waiting. I hope I am audible. All right. So let's say if some of you answer yes, sir, we should work on development of a new type of a heater because that can actually provide some kind of an impact to society. So the next thing that comes up is there are multiple heating technologies which are available worldwide. Majority of those are based on resistive kind of an heating, wherein there will be some kind of material and you apply some kind of a potential difference across it, and due to that there will be certain heat that will be generated. Now, in this particular case, if there are multiple options already available, will it be having a high impact? Answer for this is no. Now, let's say if you develop a particular heater which consumes only 1 watt energy, only one, and still is able to provide that kind of a heat which a 2000 watt heater can deliver right now, will that be having a high potential? Of course, yes. Now, in this particular case, the idea here is, if you can identify your particular passion and if you ask a particular question that if you are given money to fund something, what would you fund? And if the answer is my passion, that is the right problem on which you have to start with. Now, the idea here is whenever we talk about design thinking, we have to do few simple things. First is creative implementation. Second is efficient streamlining. Third is lateral thinking. Fourth is problem solving. Now, in this particular case, can a single person do the innovation part? Answer for this particular thing is no. Usually, whenever we talk about a particular innovation, we need a team effort. And we need a team effort so that there can be multiple ideas which can come together, where all those particular ideas can actually be explored, and maybe from all those particular ideas few important ideas can outshine, and you can start working on those particular few ideas, get that particular thing understood as a particular product, and then finally get a feedback from the consumer. And most or less this has to be a user centric kind of an innovation. Now, to understand the design thinking part, usually this particular design thinking goes in 5 simple steps. So, one by one, I will be talking about these simple steps, and then I will be explaining all of these particular steps in detail by using sort of a case study. Case study wherein we will be talking about a particular product development, and we will be learning about that how that particular product actually came into existence. But before I do that, Miss Preeti and Miss Aarti have raised their hands. So, do you have a question? Khushbu, yes, please go ahead. I hope all of you can unmute your mics and you can ask your questions. Otherwise, I will be moving ahead with the talk that I have to deliver.
Continue, sir.
Okay. So, when we talk about design thinking process, this is sort of a way where people have identified that there are 5 phases which comes into picture. And these 5 phases are named as empathize, define, ideate, prototype, and test. More or less, when people have made things in a very simple kind of a manner where empathize, define, ideate, prototype, and test, it comes into picture. This is not necessarily a linear process. In fact, when we talk about design thinking, this is a non-linear kind of a process. Yes, the 5 steps are more or less, they follow sort of a logical sequence with a set order. But design thinking itself is flexible and fluid. Many times it loops back and around and on itself. Whether when you have a particular case, when a new discovery comes in, certain phase brings it, and then you need to rethink and redefine what you have done earlier. So you will never be moving in a straight line. But of course, the steps or sort of 5 phases, they will be existing in all of those particular steps. Now, to start with, when we talk about empathize, we actually want to understand that this is a critical starting point for the design thinking process. This is basically the first stage of a process where you spend getting to know the users and understanding their wants, their needs, their objectives, in fact, their desires. And this means that for this, you need to observe and engage with people in order to understand them on psychological as well as emotional level. During this particular phase, the designers seek to set aside their assumptions and gather real insight about the users. Some of the ways how people do it is they ask open-ended questions. They identify what is the natural affinity that you can identify among all those particular users for whom you are creating sort of a solution, or for them you are creating something which is going to improve their way of life. Open-ended questions many a times help here, because when open-ended questions are asked in a particular way, that will be leaving aside the assumptions of the design people, and that is going to be a scenario where you can capture word by word what a customer desires from his or her own requirement. Now, let me give you an example in this particular case. Uh, let's say that you are traveling in maybe a railway. Okay, so you book a particular ticket. Let's say early morning, you have to board a particular train, and maybe 6:30 a.m. in the morning. So you have booked a particular ticket, you got that particular reserved number printed on that particular ticket. You reached to the station, the train arrived right on time, exactly 6:30 a.m. You entered into the bogie and you identified that, okay, there is that particular specific seat on which you have to sit. But now on this particular seat, somebody else is sitting. So what will be your first option? What you can do? Ideally, you will be going to that particular place, asking the gentleman or a lady, whomsoever it is, and tell him or her that, okay, this is my seat, I have a reserved ticket, you have to get up from this particular thing. Now, let's say in the response is, whatever is your reserved ticket, I don't care about that, I will be sitting here only. What will be your next thing to do? You will be looking for the ticket collector sort of a person, and you will be saying, okay, this is my reserved ticket, and this particular gentleman or a lady is sitting there and they are not getting up. So you can understand that this is your right, you can express about this particular requirement. Why? Because you have a reserved ticket. Okay, TT will be coming in and they will be asking that particular gentleman or lady to get up, get the seat empty, and you will be sitting on that particular place. Are you happy with this particular entire scenario? That, okay, you had a reserved ticket, you got your seat, though with certain problems, but okay, finally you are in a comfortable position. Yes or no?
No, sir.
No, sir. Why? What is your expectation?
So possibly if it would have been possible that at the very first place I would have got that particular comfort, then I might have been more satisfied in comparison to the situation that I have faced or I was supposed to go through.
Okay, perfect, perfect. Now, in this particular case, the worst case scenario is you got your seat available and you are now sitting on that particular seat. Are you happy with this particular worst case scenario?
Yes.
Okay. Now, you were able to approach to this particular TT and you were able to tell to this particular TT, okay, this is my reserved ticket. You actually complained and something happened. The issue was resolved. Wonderful. Now, let me give you a scenario which now comes up. So as soon as this particular train started, a person came to you with a wearing sort of a wonderful uniform, perfect white. Okay, that particular gentleman has got maybe a tray in his hands, and in that particular tray there are some coffee cups kept on it, and on those particular coffee cups it is written barista. Okay, and now this particular gentleman asks you, sir or madam, would you like to have a hot cup of cappuccino? The question that will be coming in your mind is, okay, what is the price? It is cold, by the way. Okay, winter morning, 6:30, you boarded the train. 6:45, you spend 15 minutes up to this particular time waiting for this particular seat to be emptied, and we are shivering in cold. And here is you have a hot cup of cappuccino. The first question that now comes in your mind is, what is the price? The answer that you get in this particular case is, sir or madam, this is free, courtesy Indian Railways. Considering the weather situations, we are providing this particular thing as free. What will be your expectation? Will you be happy?
Definitely, sir.
Definitely. Uh, You give the answer in a very modest kind of a way. Had it been me in that particular place, I would have said, wow, what has happened to this particular Indian Railways? Wonderful, great. See, the scenario here is it is a cold weather, and you actually wanted that particular coffee. You were not able to express this particular requirement to Indian Railways, and they have provided this particular thing free of cost to you. Okay, we need to understand that whenever customer requirements come in, few things will be where customer will be able to express his or her needs, desires, express, they can say about it. There are few things which they are not even assuming that this particular thing will be available. They have this particular need, they are unable to express it, and if they get it, that is something what is referred as maybe a wow kind of a requirement. So when we talk about empathize mode, here the idea here is whenever you observe, whenever you engage, whenever you watch and listen, you need to find out all those particular requirements of the stakeholders. And the requirements can be where requirements can be spoken, they can be unspoken, they can be a scenario where the requirements can be a amazing kind of a feature. That can happen only when designer team or the designers have to actually keep their feet in the feet of those particular stakeholders and identify where it is comforting and where it is painful. And that is the first step to start with. In fact, the most important step whenever we talk about product development, especially with respect to the design thinking process, empathize is the most important part. Now, let's say if you have completed this particular first step. By the way, I will be dealing with these particular things again by means of case study. So again, many things which are practical in sense will be coming there again. So talking about the phase two, which is define. So here in this particular case, it is the second stage and is dedicated to defining the problem, wherein the design team will gather all the findings from empathy stage and they start to make sense of them. What difficulties and barriers can actually come up against? What patterns can be observed? How big is the user problem that your team needs to solve? By end of the design stage, there should be a clear problem statement. And the key here is to frame problem in a user-centered way rather than saying, we need to do something like this. In fact, it should be specifically with respect to what the user wishes here. Understand, we need to understand that framing the right problem is only way to create a right solution. Now, in this particular case, when we talk about the define mode, usually constraints are identified. So once, let's say, you identify the problem, you identify those particular constraints, and then you finally come up with sort of a problem statement on which you can work. And with that particular thing, keeping customer as the prime requirement or the stakeholder as fulfilling the stakeholders requirement as the most important thing, that really helps. The next step, which now comes in this particular case, is referred as ideate. So, okay, now you have a problem which has been properly identified, but to find solution to that particular problem or to provide areas of improvement to solve that particular problem, there has to be a multi-pronged approach. Now, when we talk about ideate, we need to understand that ideation stage is a judgment-free zone. Judgment-free zone implies that there can be multiple ways how you can solve a particular problem. There is no need to pick the first thing that comes to you. If you have 10 ideas, wonderful. If you have 50 ideas, great. If you have 1,000 ideas, it's a perfect scenario. So basically, when I say that from one idea to 10 idea to 50 ideas to 1,000 ideas, basically what I am insisting here is that you have explored all the possibilities that can happen to provide a feasible solution to this particular thing. Basically, what you have to do is you have to generate the broadest range of possibilities. Here, there are multiple ideation ways what people use in this particular case. Few techniques which are usually used are referred as brainstorming, mind mapping to body storming. Many a time people follow role play scenarios. In certain cases, there is a provocation technique which is usually used in an extreme lateral thinking technique. Basically, that get designers to challenge the established beliefs and explore new options and alternatives. Maybe towards the end of ideation phase, you will be able to narrow it down to few ideas with which to move forward. So maybe even to start with, you have to start with an idea that is okay. You have to build castles in air, but yes, castles in air cannot actually be built. But yes, that is the way from where you have to start. Now, from that particular hundreds and thousands of ideas that come up, you will be coming down to few from where you can actually start working towards the solution part. Here we have to understand that if the team is bigger and if that particular team is interacting with the stakeholders multiple number of times, we can easily uncover the unexpected areas exploration, and that can provide better and more number of innovation options. Moving this particular thing to, let's say, the step 4, which is prototyping. And in that particular case, the thing is you have to reach to a level where you can tell what you ideated. Now, to give you sort of a starting point of this particular prototyping and relating this particular thing with your own environment, uh, can you remember, let's say, the first day when you were taken to a school as a kid, maybe in your nursery or maybe in your lower KG class? Maybe not many of us here will be able to remember that particular day. But we all are adults, and maybe we have seen those particular scenarios where we have taken our own kids to schools, or maybe some kids which are from our neighbors or maybe our relatives, the first day when they enter into a school. 90% of the cases when these particular kids enter into a school, the first day they will be horrified. They will be having those particular cases where they will not be very happy with that particular change circumstances. How schools handle to that particular scenario? Of course, having a very good behavior, having very good interaction, that is one particular thing how to start with. But one common thing what people do is, okay, take a paper, take sort of a crayon, and try to make something from it. So usually with few days passed on, those particular kids are able to maybe mark something on a paper in a way where it is easily not recognizable. But over a period of time, you must have realized up to a particular scenario where they are able to make maybe a small hut, maybe a small tree, maybe some birds flying by, maybe sort of a shape which represents like a human figure. And these particular kids are too happy about their creations, and they show those particular creations to their parents as well as to the teachers, everybody with whom they come into contact. They are proud about it. Many a times in this particular case, you as an adult will be not able to realize that what is the exact shape that this particular boy or a girl has made on this particular paper. But of course, there is something which can be seen. Few years down the line, some of those particular kids will be making shapes which will be far easy to understand, far easy to relate with it. When we talk in terms of engineering, something which is now coming in as fourth phase of design thinking is prototype. And this fourth step is all about experimenting and turning ideas into something which is visible. Visible primarily in terms of a drawing, or maybe as a tangible product, maybe a scaled down version of the product which incorporates potential solutions which were identified in the previous stage, maybe a thermocol model, maybe a 3D printed model of the final product that has to be there. This step is key in putting each solution to test and highlighting any constraint and flaws. And most importantly, at this particular stage where prototyping comes into picture, once you have the prototype ready, you can show this particular prototype to the stakeholders, the customers, and you can identify what are the flaws. And with those particular flaws, you can again go back to the scratch, again start working on the empathy model. Maybe there is something which I missed when we started. So let us incorporate now with this particular feedback, and then again provide a improved version. So throughout the prototyping stage, the proposed solution may be accepted, may be rejected, improved, redesigned, or depending on how they fare in a prototype form. The question is, do things do? Do things do what? Do things do that particular purpose for which you have actually incorporated certain kind of a change? The idea here is we have to build certain solution in a faster and quicker manner. If we succeed, perfect. If we do not, we should fail quickly and cheaply. And that is why I said using those particular thermocol models, or maybe some sort of a drawing followed by some kind of a model, or maybe having some kind of a 3D printing coming into picture. Basically, what you want to do is you want to test a number of possibilities. And once you do that particular part, then you can actually come up with the last stage, which is testing. Now, when we talk about testing, the question here is whether it worked. So after prototyping, when we go with the testing part, it is important to note that this is rarely the end of design thinking process. In fact, if you do this particular testing, this is an opportunity to learn about the solution and your user. And many a times, if it is the last step, this implies your stakeholders are happy. They are comfortable with the kind of change that you have provided in your ideation stage and shown to them to up to the prototype stage. But if this particular testing requires maybe certain feedback where you need to go back again, that is how you can identify that we are not moving in a sort of a linear direction. In fact, we go in sort of cycles and cycles. Design thinking itself is an iterative process. It will take multiple iterations. It will take time. But whatever that comes out from this particular entire approach, that will be useful because you have feedback from the consumer right from the starting point. So if I have to summarize, the result from the testing stage will often lead you back to previous step, providing the insight you need to redefine the original problem or come up with the new ideas you hadn't thought of before. So in this particular case, the idea here is whenever we test something, we show, don't tell. And that basically helps in creating user experiences wherein users can actually compare what they had earlier and what they have right now with them. So in that particular case, things can actually come up in a far better way, and you can provide a far better solution in this particular case. The idea here is do those particular iterations and then go ahead. Now, once I complete this particular 5 steps, I will now quickly taking you towards the case study where one by one we will be learning about all of those particular steps in an actual scenario. Before I proceed, there is a word of caution. There will be few materials, few images which you will be seeing in coming slides where user discretion is mandatory, where do not get troubled by some of the images. All right, so here you have 2 images in front of you, where one particular image is with respect to a issue which is named as cleft palate. where this particular cleft palate is a deformity which is there in this particular child. The second case is where you have a cleft lip, the first image, and cleft palate, the second one, where in both those particular cases you will identify that some portion on the cleft lip part is missing. Again, with the cleft palate, some portion is actually missing. So usually this is kind of a genetic deformity. In certain cases, it can be due to some kind of an accident. In certain cases, a reason can be multiple. And if you have, let's say, this kind of a kid in a family, the life of that particular family is not very comfortable. Of course, the life for the kid itself is in a very bad kind of a way, because imagine a scenario where if you do not have a palate, how difficult it will be for someone to drink water, maybe breathe in or breathe out, how the voice is going to come out while this particular kid is trying to speak. If there is something like a cleft lip, the shape of that particular lip is again not a very good thing to see. So every year in US, over 5,000 infants are born with cleft lip or palate, about 1 to 2 per 1,000 births. In India, the occurrence rate of this deformity is something around 1.09 for every 1,000 live births. So though the number is not very much, but looking at the kind of population which we have, the cases where cleft lip and cleft palate are huge. And right now, why I'm showing you these particular figures are because we are talking about the first step of design thinking, which is empathize. In empathize, what we want to do is we want to understand what are the requirements of our stakeholders. For them, can we do something in this particular case? So the key question that now comes in is what can be done for this particular problem. So idea here is there can be surgical correction so that there can be a constructive surgery wherein if this particular palate can actually be developed, or maybe in certain case if the lip is missing, can that particular lip be constructed in a way so that that particular correction can be made, and finally the face or the palate part, they all can be actually developed. Now, in this particular case, the usual procedure here is, for example, if this is the mouth of that particular small kid, incisions are made, and with those particular incisions, the palate portion is then developed. It is basically joined together. Now, here in this particular case, for making an incision, that is referred usually as dissection. That is a serious issue. I will be reading as it is what is there on my slide, just for you to be accustomed with the kind of issue that we are dealing. Separation of dense fibrous unions of the mucoperiosteum with the thin palatine bone is needed. Now, this requires tough dissection with a very tender instrument, maneuvering through small oral commissions of usually very young patients. During this dissection, tissue planes may get mutilated, leading to bleeding and thus further compromising the visibility. So, idea here is you have to actually build this particular palate. So, how do you do it? You make certain incisions, you dissect it, and then you stretch the skin, and then you try to stitch it together. Now, in doing so, a small human patient, let's say age 1 year, 2 year, the oral cavity is very small, and it is very difficult to actually look inside that particular case, do all the corrective procedure, and then finally come out with best possible results. So what people have done is, okay, you do not use sort of a knife. In fact, you use a particular approach which is named as hydrodissection. Hydrodissection. And mind it, here we are talking about those particular cases where we want to understand what is the real issue. We are under the empathy mode, the empathize phase of the design thinking approach. So in this particular hydrodissection case, liquid is injected at high pressure, and this particular liquid makes its way into the tissue plane, creating a safe cleavage between tissues even before the knife is used. Now, to show you how this particular thing actually works, I will be showing you sort of a figure. So this is basically sort of a hypodermic syringe, which is usually used to provide hydrodissection part. Here, the needle portion is inserted, and with this particular needle, fluid goes in, wherein this particular fluid goes between the bone and the tissue part. And when the pressure increases, hydrodissection procedure happens. And here you can observe that this particular portion is getting separated. So you are not using a knife here in this particular case. Instead, you are using syringe pressure. Now, if you have to actually see in this particular case, very small oral cavity, and with that particular small oral cavity, doing this entire surgical procedure is a bit of issue. Now, question that now comes in is, does it help? So whether this particular hydrodissection approach, instead of using a knife, whether this particular thing is going to help? The answer is, of course, yes and no. Now, why yes? If yes, then how? So hydrodissection provides a rapid expansion of usually sparse palatal soft tissues and thus facilitates a easy and tensionless repair. And there is very less minimal kind of a bleeding, in fact, no bleeding at all. Palatal fistula rate, which is earlier happening when knives were used, they were in range of something around a very high number. However, in this particular case, the fistula rate is only 3%. Recovery rate is far better as compared to the knife one, and most important is it is beneficial for the surgery. Now the thing is, why no if everything is so good? Now, first and foremost thing to understand here is, even if palatal fistula rate is only 3%, still that particular 3% exists, and that particular thing is a big number. So for every 100 cases, 3 will be having this kind of a issue, which is not a good thing. Now, few more things which are slightly not so good are, number one, it is harmful for surgeons' hands. Now, imagine a particular case where you have a syringe in your hand, and with that particular syringe you are applying pressure so that saline fluid is going through that particular needle, where this particular fluid is entering in the cavity between bone and tissue, and then you are applying pressure, force and more force, so that the hydrodissection procedure is happening. Now in that particular case, there will be serious kind of an effort that is required, and that particular serious effort will generate fatigue and pain in the hands of surgeon. Now usually when we talk about cleft palate and cleft lip kind of a surgery, this particular surgery is done by plastic surgeons. Plastic surgeons are a breed of surgeons who are who should be very sensitive to what is going on in their with their environment. In fact, the kind of refinement that is needed with plastic surgery kind of a field is far higher as compared to the general surgery kind of things. They have to have a class in a way how they work actually. So imagine a scenario where you have to actually apply huge pressure through this particular syringe, and maybe there can be a case where a surgeon is operating for 10 or maybe 12 cases a day with similar kind of a procedure. What is going to happen to his or her hands? So that particular repeated stress, and due to that certain injury, it reduces accuracy of the skill. One more thing is, if we go back and if we look at this particular specific figure, imagine a case where you are exerting huge amount of force from this particular syringe, wherein while needle is inserted in, there is any kind of a lateral movement in the syringe because of huge pressure that is being exerted while you are pressurizing the plunger. That may even shift the needle from its position, and that particular lateral movement can create trouble to the patients. So that also needs to be controlled. So the idea here is, can you do something so that the 3% palatal fistula rate is reduced? can you do something so that while providing this hydrodissection process, there is no movement of the needle, there is no extra force which comes or which gets exerted while providing this particular hydrodissection? By the way, during this hydrodissection, medium nerve is compressed at the wrist, resulting in numbness and pains. The option right now here is surgeon knows that there is something wrong with his positions and actions, his or her position and actions, but the level of stress during tedious surgical procedure gets transferred to the mind and body of surgeon, and usually he or she makes himself or herself understand ये ऐसे ही होता है. This is right now the empathy mode. Now what? As a design thinking team or one particular person who wants to do some change, can we do something here? Now, there is something which is referred as ergonomics, also named as study of human factor. Now, in this particular case, surgeons are usually not tuned to ergonomics and they cannot actually design and develop surgical instruments. They can be quite good in finding the ways how to lower down that particular effort. But yes, to develop a surgical instrument, some sort of an engineering understanding is required. Maybe some sort of analysis is required. So for that, can engineers come into picture? Answer is of course yes. Engineers can design and develop, but they do not feel or understand the requirements of surgeons. So we need to actually provide sort of an amalgamation between surgeons and what engineering people can do, and that particular amalgamation can result in something which can be a good product. We are still in the empathy mode. Now, let's move this particular thing to the next step, which is define, where we have to design options and we have to identify certain constraints. So, if we have to find a ready-made solution for this particular thing, can we explore what are the other commercially available devices for doing this kind of a job? And if we can actually find out, can we actually come up with sort of a product which can serve the intended purpose right at this particular point of time? Let us explore. Remember, we often said that whenever we talk about any kind of a design thinking approach, the first starting point can be what you look from your environment. So, finding what is available with commercially available devices, there were certain problems which were identified. First one is they can inject only small volumes. Any device which can actually deliver this kind of a thing, for example, a motorized device like a syringe pump, they are unable to work under the kinds of pressure that is required here. Most important thing is with those particular devices, tissue feel was not possible. Tissue feel implies that while a surgeon is operating using this particular device, that particular tissue is not felt. So basically, it was kind of a mechanical kind of a thing. Many a time devices were quite big and they cannot enter the very small oral cavity. So the idea here is, while defining the problem, we need to provide a way so that surgeon can feel the tissues, it can feel the resistance during the dissection, the giveaway feel which is coming up, so that that particular feel can give a guide to surgeon for its or her surgical maneuvers. Now, coming to the objectives, what we want to do here is we want to reduce surgeon's discomfort. We want to improve the efficiency and convenience of surgery. We want to reduce the rate of complications, the parallel fistula thing, and the time taken to dissect the tissues in an RDS field. One most important thing that now comes in is, which you all have to remember throughout your lifetime, is it is always better to find simple solutions for complicated problems. Simple solutions for complicated problems. If you are able to find out, let's say, a complicated solution for an already complicated problem, maybe users will be having certain issues in adapting to that particular solution. But if the solution is simple, they will be ready to adapt it. Reaching to simple solutions may be complicated, but simple solutions will always be the best ones. Okay? One humble rule that we have to follow is good design is simple, and that is why it is so complicated. Don't make things complicated. Now let us enter into the next stage, which is ideate. Now, when this particular ideate stage comes, many a times thousands and thousands of different ideas will be coming in. When we developed this particular equipment, yes, we had all those particular ideas. In fact, we had multiple iterations. With those particular iterations, we performed different inputs, many multiple feedbacks, and finally, we came up with one particular equipment which can actually serve the purpose. With multiple iterations which came up from ideation, I am presenting you one particular last thing that came up, and that particular thing is named as a hydrodissection device, which is also popularly known as syringe pressure gun. The idea here is this is based on principle of lever and ergodynamics. It reduces surgeon's discomfort, improve the efficiency and convenience of surgery on one hand, reduces the rate of complications, reduces the time taken to dissect the tissues in an RDS field. So whenever you press this particular lever, let's say once, this particular lever pushes plunger so that 1 ml of fluid goes out from the needle. So if it is, let's say, 20 times pressing, you are able to put in 20 ml of fluid. Now, here, if you look at the shape of this device, a majority portion of this particular syringe is something that can easily be inserted in that particular small oral cavity. And while surgeon is operating on this particular thing, he or she can actually hold it in his or her hand firmly, because this particular grip looks like sort of maybe you are holding a pistol in your hand. That is why the word gun come into picture. And while this particular surgeon is holding, it's stretched at his arm's length, and if, let's say, if visibility is not obstructed, so you have a particular device where everything is simple, where just by pressing this particular lever, you can provide a particular flow of saline fluid for hydrodissection part. Visibility is not affected. The surgeon discomfort is not there. And most importantly, this device reduced surgical time to 50% from the original hydrodissection method, and the palatal fistula rate from earlier best reported values of 3% to 0%. 3% to 0%. So now everything is good. Till now, something around 15,000 operations of cleft palate repairs have been used by using this particular device. And mind it, I'm talking about a data for a single hospital. Single hospital. Okay. I am now at fifth step of design thinking. Is the design thinking approach completed? Answer is no. Remember, when I started, I said, is design thinking a linear process? I said, no, it is not linear. It is flexible and is fluid. It loops back and around and on itself. We need to remember this particular thing, that whatever may happen, areas of improvement will always be there. So even if you do something in best possible way, there will always be a better improved version which that can be made. So this is one particular case where testing, which has received certain feedback from the consumer, with that particular testing, some good results come out. But should we stop here, or should we go with maybe further improvement on this particular process? So the idea here is, if we can restart this particular entire thing, or maybe start from that particular original position from where we actually started, the empathy mode. Can we do something so that the time that is required for surgery can be lowered? Can we do something so that the cost element, we can take care of that particular part? Can we do something so that repeatability is not an issue? Can we do something so that the kind of resources that were involved in this particular device, they can be lowered down? Can we lower down any kind of a risk which get associated? So the areas of improvement then came out is it possible to develop a fully automated device, still get that particular feel of dissection while the device is being coming into picture? Is it possible to have a feedback mechanism with the device, because the current device that is developed, that has been used for operating more than 15,000 operations, that particular thing does not give you that specific recorded feedback? Is it possible to provide a real-time monitoring of what is going on and monitor the data as well? Is it possible to have sort of a smooth injection without any pulses? Now, if you look at this particular device, what we have earlier seen is as soon as you press this particular lever, there will be 1 ml of fluid going in, but that will be in sort of a pulse. It is not going to be a continuous movement. Okay. Second, in this particular case, the cost that came up for this particular device was very less. It costed something around 300 rupees only. So, okay, the device seems to be quite simple. And most important part here is, since this entire device is sort of a modular structure, it can easily be sterilized. So you can take it apart into small pieces, keep it under an mic in an autoclave kind of an instrument, and you can easily do it. Replacement of this particular syringe from this particular device was always an easy part, because this is open from one side. So you can easily spread, take apart the syringe and fill in and replace it with a new one. But is it possible to have sort of a feedback device? And is it possible to have an automatic device without any kind of a pulse? So now coming from that particular empathy stage to the next stage again, which is define. So yes, when define comes into picture, we have understood that the device has to be an automated one. This implies we can now ideate in a way that what are the ways to automate this particular thing. When feedback mechanism is required, this implies there will be certain needs of sensors so that they can actually understand that what is the kind of pressure that is coming in, what will be the flow rate that is coming in. When real-time monitoring data recording comes in, that also defines that, okay, you need to have some kind of a log of the pressure, of the uh, flow velocity that is coming into picture, and with respect to the resistance that that particular syringe will be getting in while it is dissecting the plane between the bone and tissue. With that particular thing, the next stage ideate comes into picture. So now let's say when we talk about sliding mechanisms, which can be used as an automated kind of a system, there are multiple ways. And here knowledge with respect to, let's say, the design part comes into picture, that what are different ways how sliding mechanisms can be varied. Can we have, let's say, a complicated kind of a system? Can we have a system which is again quite simple, but that also provides sort of a jerk free and smooth system? But most important thing is, while this particular needle is being getting inserted between the bone and tissue, the kind of pressure that it has to exert is huge. So you need to have a particular system which can actually withstand that kind of a pressure and still move in. Now, to do that particular thing, there will be requirement of some kind of motor. It can be a DC motor, it can be a gear DC motor, it can be a system where you can use a pneumatic or a hydraulic system. It can even be coupled with sort of stepper motors or industrial servos. Now, we need to remember that whatever device that you develop next, that particular device should again be handy, because surgeon has to hold this particular device in his or her hand. Second is, device that you use, that particular thing should be able to be sterilized. So the thing has to be sort of modular in picture so that it can easily be sterilized. It has to work in a zero bacteria environment. The next thing that comes into picture is the visibility of surgeon. That particular visibility should not be affected. So whatever raw materials that you are using, those particular raw materials, what are mechanisms that you are using, those particular mechanisms, whatever sensor that you are using, everything has to fulfill all of those particular prior requirements. With this, one particular design evolved. Now, this is sort of a CAD model of a new design wherein there will be sort of a grip. With this particular grip, you can hold the device. There will be sort of a motor which will be providing that particular movement. Here you can place your particular syringe and you can provide sort of a sensor somewhere here to sense the kind of pressure that is being exerted. Now, this is a prototype one. So right now what we have done here is we have again rewent that particular wheel from empathize to define, define to ideate, from ideate to next step of prototyping. So this is how the new system looks like. Here you have this particular sort of arrangement, which is again a modular one, which is connected to a microcontroller, which basically senses the pressure that is being generated during the hydrodissection part. And with that particular pressure, it basically controls that how much forward movement this particular thing has to take to provide that particular hydrodissection process. Now, there can be an issue where, let's say, this particular device goes in, let's say, a hand of a not so well surgically trained person. Okay. Now, in that particular case, what can happen is maybe this particular device actually goes inside the bone because this particular person has handled it maybe in an improper way. So in that particular case, what can happen is there will be huge pressure rise as saline fluid is pushing in. Device has to automatically take care of this particular scenario where it will stop the supply. So there has to be some kind of an automated system where the system identifies that, okay, this is not a normal circumstance, something wrong has happened. So more or less here, if there is any error on part of the surgical team for operating the device can automatically take care of that particular part. Okay. Now, did this particular prototype serve well in the test part? Answer is no. Remember, design thinking is an iterative process. So now in that particular part, it was identified that, okay, yes, while you have all those particular things coming into picture where you have all the microcontroller things coming in, they can work in sort of an automated kind of a manner. But in reality, the movement was not that good where it can actually sustain the kind of pressure requirements for this particular device. So maybe you need to actually change this particular design so that the pressure requirement can actually be met. So few more iterations where design improvement comes into picture. Remember, we are now going back to our state from test to empathize and then empathize to ideate. Again, coming back to this particular ideate stage. So here, providing some sort of extra arrangement so that movement of plunger becomes easy, providing sort of a way where the pressure that is being generated, that particular thing is sufficient enough to do sort of a hydrodissection process. Finally, the new design came into existence. And with this particular new design from ideate, you will be going to the prototype stage. And from prototype, you will be then moving again to the test stage. So after many design iterations, that is many cycles of ideate, prototyping and test, you have the final device ready. And the best part about this particular device is this particular device can actually sense the tissue density for, let's say, a child who is 1 year old, a child who is 1.5 year old, 2 year old, or maybe even 5 years or 10 years old. And with that particular tissue density, it takes some corrective action that how much fluid pressure has to be provided for completing the hydrodissection sync. So few initial trials where the device is being tested on sort of a scaled model. From that particular model, taking or collecting that particular data that is required, and from particular data analyzing it, that okay, what corrective action the device has to take, the final process actually goes on. Now, with this particular thing, many a times there will be certain feedback that will be coming in from the team of surgeons that okay, we do want this kind of a thing, we do not want that kind of a thing. That again will be taking that particular loop of design thinking. Remember that satisfying stakeholder is something that is very important, and if you can do that particular important thing, you are doing things in a far better manner. So there are still certain more improvements that are now desired, and those particular improvements are: is it possible to increase the feed rate of syringe plunger? Is it possible to improve the design for, let's say, providing better smoothness to the slider? Is it possible to increase the push force? Is it possible so that whatever wiring that you are having for this particular device, it should be enclosed? Is it possible to use some sort of a silicon pipes for covering wires and so on? With many iterations, finally there is now an improved design. So again, what we have done here is all following those particular 5 phases, those original 5 phases which we actually started with: empathize, define, ideate, prototype, test. Here is that particular final improved design. Now here, if you look at this particular thing, the idea is there should be a complete modularity which should be available for this particular thing. The data has to be recorded. That particular data has to be recorded as this particular device progresses. This particular data has to be recorded and analyzed in a way where microcontroller can be fed in sort of an algorithm. So, okay, for this kind of child, which is of this particular age, this will be the tissue density, how the hydrodissection pressure has to come into picture. Now, let's say if the device has to work in an automated manner, wonderful. Alternatively, if surgeon decides to provide a manual override on that system, for that particular thing, a manual override should always be possible. Override both for forward as well as retraction. Override where this particular override also sees the kind of pressure that is being generated for the hydrodissection process. This is the actual prototype, which is the final device which can actually serve the purpose. By the way, most important thing which is very important for this particular part is whatever design that you make, you have to actually ensure that that particular design goes in right way so that this particular design can actually be produced. And one of the best possible way to do that particular thing is to save your intellectual property, because that will be your first starting point, which can actually say that yes, this is your own design, you have developed that particular thing. So this is one particular slide which talks about that the device has been filed with a patent way back in 31/10/2019, and considering the inputs which we had for development of this particular device, Mr. Rajendra Arya was basically my student who did his PG and PhD with me, and development of this particular device is not part of that PhD or ME thing. This was basically sort of a social work which we took to do some kind of an improvement for the kind of ordeal that cleft lip and cleft palate patients face. And just to provide sort of a certain improved scenario, we developed this particular device. The thing here is that whenever you have any kind of an idea, you need to actually ideate, prototype it, test it, and finally go to the market so that that particular thing actually comes into action. By the way, this particular happened. This particular device was also sort of a showcase instrument, which was shown to a conference by World Health Organization, wherein worldwide people actually identified that this is a good effort. And most importantly, from this particular conference, we were given a feedback from people who work in field of dentistry that this particular device can actually be used for some of their operations as well. So of course there are certain customizations required, and those customizations are according to the software requirements. So again, getting those particular feedback, again following that particular design thinking. Of course, remember, it is an iterative process. That particular sequence goes on and goes on and goes on. Now, most important thing that comes out here from this entire discussion is, whenever we work on design thinking kind of an issue, we have to understand that design thinking is especially useful when it comes to solving wicked problems. Wicked problems. Okay, wicked problems basically can be understood by a simple thing, that these are tricky problems that are highly ambiguous in nature. There are many unknown factors in this particular thing, and there are no definitive solutions. In fact, solving one aspect of a wicked problem is likely to reveal any other problem in a different kind of a challenge. So some of the, let's say, wicked problems in our society include things like maybe poverty, hunger, climate change. Those can be few important things in which we can actually start working with the design thinking approach. Most importantly, if we can do something for some of the latest areas which have evolved over a period of time. Just a minute. Yeah. So some of the areas in which we have to actually use this particular design thinking approach, because those are those areas which will be, which can be referred as areas for current as well as the future. They are: number one, advanced manufacturing; number two, industrial automation; number three, smart factory, digital manufacturing, data analytics; then smart city, smart infrastructure, e-mobility, healthcare, medical equipment, electronics and semiconductors, and finally maybe the energy part. So even if you belong to, let's say, a different field where that particular field is related only with the core branch of
Excuse me,
engineering,
sir.
that particular thing can actually be clubbed
Presentation.
in where you can do something good for the society.
Excuse me, sir.
Yes, 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 संजीव जी बताइए.
Screen is not visible, sir.
मैंने स्क्रीन बंद कर दिया है.
Okay, sir.
Okay.
Okay, sir.
I am not showing anything. That is why that particular screen is not visible.
Use our screen.
What did it say to him? So the thing here is, can we stop at, let's say, the kind of work that we have done up to this particular point? The answer for that is no. Remember, if you know your passion, if you know your strength, the tools and techniques, the knowledge that you get maybe from your engineering study, or maybe some other subject that you study, or maybe from your own environment, and you can find a particular way which here your work can have a high impact. That is something which is really required. And of course, design thinking is a wonderful approach to work in that particular direction. So with that, I will be finishing my talk. And now I am opening this particular session for any kind of an query that comes in.
Yeah, I'm opening the session for any kind of discussion, I think.
Yes, any queries, please ask.
Yes, sir. So first of all, sir, the session was really very informative. Thank you so much for such a nurturing session. Secondly, I had a question that this domain design thinking, is it restricted to scientific and technical field only, or it can be like enlarged to a larger field, like say for example social sciences?
Okay, Ria, thank you for your wonderful comment. Your answer to your particular query is this particular domain is open to everyone. Now, since I am a mechanical engineer, I will be thinking things from my own perspective. And since I have worked in certain healthcare devices, I bring a case study from that particular domain. All right. So, yeah, this is applicable for all the fields, even if it is applicable for UI and UX kind of a people.
Thank you, sir.
Any other queries from participants? Anybody wants to ask anything to sir?
Okay, no questions.
No queries, sir. So it was very interactive, interesting, and wonderful session, sir. Participants definitely have get benefited from your talk, and we are very thankful to you for accepting our invitation for being expert in this FDP, sir. Thank you. Thanks a lot, sir. We are seeking for your guidance and blessings in the future also, sir. Thank
Thank
you.
you. Thank you, Dr. Indo. Thank you, Dr. Ranjit. Thank you, all
Thank you.
participants. And we will be having another session on Wednesday. So maybe
Yes, sir.
we can take this particular thing to a different level that day. Thank you.
Yes,
Bye.
yes.
Thank,
Sir, just one thing I want to ask is, can you share this PPT? It would be beneficial. Will you
Yes,
be
yes,
sharing?
yes. I will share the PPT with Dr. Rathod. Okay.
Okay, thank you, sir.
Okay. Bye
Thank
bye.
you. And participants, you are requested to join back at 2:45 p.m. We are having second technical session of Dr. Professor Pradeep Kumar of IIT Roorkee. So we will be joining back at 2:45. Thank you,
Okay.
sir.
Bye.
thank
Thank
you,
you.
sir. Thank you.
Thank you.
Thank you, sir.